This is a University of Otago podcast.
Inga mana, inga reo, ro rakatidama, tenakoto, tenatato katoa. My name is Harlene Hain, and I have the great pleasure of being the Vice Chancellor here at the University of Otago, and it brings me great pleasure to welcome you to this inaugural Professorial lecture. As always, it's fantastic to see so many staff and students from around the University of Otago, and it's also fantastic to see members of the University Council and members of the Dunedin community. I'd like to extend a particularly warm welcome to members of Holger's family who are here with us either in person or in spirit. His partner Claudia is here with us in the audience this evening, but I would also like to acknowledge members of Holger's family who are watching this via live stream in Germany and in Invercargill. And in addition to Holger's family, there are also folks here from the Polytech, from other local businesses in Dunedin, from the Methodist Mission, and from the volleyball team. Now, the range of people who have gathered here with us this evening to celebrate Holger's promotion is a testament to his reach, the reach of his research within our larger local and national community. Like all professors here at the University of Otago, Holger has excelled in teaching, in research, and in service. He is widely recognized as New Zealand's leading researcher in the area of virtual worlds and augmented reality, and his work is highly respected and highly cited. I am very much looking forward to his lecture this evening. So Holger, on behalf of the University of Otago, I would like to warmly congratulate you on your very well-deserved promotion to professor. And I will now call on Professor George Benwell, the Dean of the Business School and the Pro-Vice Chancellor of Commerce, to tell us just a little bit more about Holger's academic history. Nō reira, tēnā koutou, tēnā tātou katoa.
Vice-Chancellor, Deputy Vice-Chancellors, Professor Regenbrecht and family, present and distant, colleagues, ladies and gentlemen, it gives me great pleasure to introduce Professor Holger Regenbrecht. Professor Regenbrecht was awarded a doctorate in 2000 from the Bauhaus University of Weimar, I hope that's reasonable pronunciation of German, in Germany. The term Bauhaus stands for an eagerness to experiment, openness, creativity and internationality. And we witness those qualities in Holger's work and his research even to today. He's been working in the fields of virtual and augmented reality for over 20 years, despite his young look, both as a practitioner and as a scholar. Thank you for augmenting our reality this evening. Holger joined the University of Otago Department of Information Science in 2004 as a young senior lecturer and has progressed steadily through the ranks to his present professorial appointment, a promotion justly deserved. An important aspect of Holger's past is that he worked in mixed reality for DaimlerChrysler Research and Technology laboratories in Germany. There he learnt the essential business skills of programming, client relations, and to speak the common interface language of the difficult professions, excluding law, of architects, civil, automotive and aerospace engineers, and of health and well-being professionals. It comes as absolutely no surprise, therefore, that Holger relates exceptionally well to people across the education spectrum, and he now leads our Computer-Mediated Realities Lab, spanning commerce, sciences and health sciences. Professor Regenbrecht's research interests include human-computer interaction, applied computer science and information technology, remote collaboration and communications and computer-aided therapy and rehabilitation, to mention only a few. In these areas, he's published over 100 peer-reviewed articles, and there have been over 2,500 citations of his work. And because he's a mathematician and a programmer, I worked it out for you, Holger. That's 1 citation every 3 days for the 20 years of your career. Pretty onerous and respectful output. He is a member of the EEE Computer Society, the Association of Computing Machinery, and the Association for Information Systems. Holger continues to serve the university at all levels. He is the outgoing, well actually the gone, Associate Professor of Research, Associate Dean of Research for the division, and he's about to become the next Head of Department for Information Science once he recuperates after a period of research and study leave. Since coming to Otago, he has received significant external funding for his research and to support his graduate research students. Internationally, over the last 20 years, he has supervised over 55 graduate students, including 15 PhD students, and he has been an examiner of over 23 graduate dissertations. It is to my personal satisfaction that I was fortunate enough to recruit Holger back in 2003. And it is equally pleasing to me to see that he has developed into a leading academic in this great university. The accolades for his development belong entirely to himself, and I'm sure are supported by his loving wife and daughter. Colleagues, it is my pleasure to present to you Professor Holger Regenbrecht. Tonight he will present a lecture entitled Seeing is Believing, Exploring Computer-Mediated Reality. Professor Holger Regenbrecht.
Tenatatu katoa. It's good to see so many people here. I'm really surprised. I thought I will give a lecture in a half-empty lecture theater, but yeah, the opposite is the... So thanks for coming. And thanks for the nice introduction of from the Vice Chancellor and the Pro-Vice Chancellor here. Yeah, seeing is believing, and this was actually the other photo which was taken for this inaugural professorial lecture, and I thought, do I use that one or the one you have seen? But I decided for the more formal one, so I saved that for this lecture. So what I want to talk to you about today is not all the projects I did in the past and all the theories I used and applied and all the maths, and I will save you from that. I will talk about what I'm most passionate about in my research, and that is what is that virtual reality? What makes virtual realities actually virtual realities? What is it? What is the essence of it? And I'm in search for that for over 2 decades now, and you will see why that is the case. Yes. So let's start with where it all began. It began all with a green cube. So this was the first thing I programmed in virtual reality, a wireframe green cube. And that's actually, as Jeff would know, 25 years before me that it's failed. Why failed? Why it failed? Better? He implemented a green wireframe cube, and that was his virtual reality. And it's the same as for me. So I implemented that green wireframe cube. And to explain that to you, what is the difference between seeing that wireframe cube not on that slide or how I experience it, I explain a little bit how virtual reality works, right? So you're wearing a head-mounted display, and that's a display you are having in front of your eyes, 2 tiny little monitors with lenses in front of it, so it makes the world bigger, and then you're entirely enclosed in that world, right? So you only see your virtual world. Then you can walk around, and the computer generates displays for you, right? It generates the content of the scene. So that green wireframe cube I would see in front of me, and I can walk around and can look at it from different sides. And I see it from the right perspective, the right angle. It will get closer, it will be bigger. Get further away, it will be smaller. This is how virtual reality works. So 50 times a second, the computer generates a new imagery for me so that I get the impression that that green wireframe cube is there, right? The disappointing part for me was when I programmed that and I took off the head-mounted display that reality disappeared. So the green cube was not there any longer. I produced it. It was there. I saw it. So it was a really an exciting experience, actually. And since then, I'm in search for that thing, for that essence? What makes it that I was so disappointed when I did not see my green cube any longer? To tell you a little bit about technology, to make that happen, you need a little bit of technology and skills, right? So you need a head-mounted display, as you can see there in that photo. That is that thing you wear in front of your eyes, right? And then the computer has to know somehow your position and orientation in space, right? So if it has to produce the right imagery from that side, it has to know that I'm here and I'm looking into that direction. And if I go over here, then we have to know Holger is now here and is looking into that direction. So normally we use tracking systems for that. Well, that's a classical tracking system we used back then, a Polhemus magnetic fast tracker. It's a tiny little thing, you mount it to your head-mounted display, and with that, the computer gets the signals about the position and orientation of the user in space and can calculate the right imagery, right? You need a powerful computer. Back then, this is a Silicon Graphics Crimson VGXT super graphics computer. $250,000 for that machine. And I had probably the cheapest machine in the whole country. So that was the minimum required equipment you need to run a proper virtual reality experience like my wireframe cube. Okay? And what you need in addition to that is, of course, somebody who creates that world, right? You need a computer program, and that looks more or less like this. And Jeff might remember that. That's not OpenGL, it's still SGL. And so you program that. You say a line goes from there to there, from there to there, from there to there, and that line is green, and it is in that position, and then you take in all these tracker data, and then you do a perspective projection, a little bit of math, and then you see that wireframe cube. So it takes quite a while to produce that impression, right? So I was totally excited about that experience of my green cube. Okay, but I continued, of course, with that and tried to explore lots of different avenues. Where can I find out more about virtual reality? Others had bigger machines and worked in it for a little longer. It was the mid-90s. And so we read Mondo 2000 back then about virtual reality and new geekery and new technologies and cutting-edge technologies. We read everything about the 60s and the 70s, about Timothy Leary's drug experiences, about Neuromancer from William Gibson, Neil Stephenson's Snow Crash, all these beautiful things. We listened to music by Laurie Anderson and other avant-garde musicians, right? Just to find out, that's the feeling of the time. That's the vibe of the time, right? But that was not enough, right? I wanted to see it, I wanted to test it in action, okay? So because my abilities weren't there yet, and to program real, rich virtual environments, and I did not have the technology either, I went to so-called virtual reality cafes. So back in the mid-90s, we had those virtual reality cafes, like you have had internet cafes. So you could go there, and you done a head-mounted display, and you play a game, like that one, Dactyl Nightmare, right? So you have to shoot flying dragons, right? So I went there with friends and people I know, and we tested that, right? And we observed them and how they react in those environments. It was very interesting. It was very interesting to see that they start to duck and to be scared in those environments. And it's virtual, right? It's computer generated. Why would I be scared in such an environment? So still that big mystery about virtual reality, right? So that was my first mystery. So I teamed up with a psychologist and friend, Thomas Schubert, and we thought of an environment which really, really makes you present or immersed in that environment. So what can that be? So we use a situation we all try to avoid, which is fear, right? So if you feel fear in a real environment, then you're probably very much in that environment. So we use that and produced a fear-stimulating environment. In that case, it's a fear of heights-producing environment. So if people feel fear in that environment, then we can be certain that at that very moment, they are inside of that world. So then we can observe them, right? And we observed them. In that case, we had about 40 people trying that very primitive virtual environment. People were wearing these head-mounted displays, could walk around in a space of about 4 meters in diameter. And then there was a bridge, and there was about an 8 meters, virtually 8 meters deep gap, right? So even I hesitated to step into that gap, even if I programmed every single thing of that whole environment. And I saw people crawling on the floor, with the head-mounted display on. So there was something going on here. Seriously going on. So very nice experience. So then I thought, oh, I'll make a PhD out of that, right? So now I know how we do that. So I wanted to, actually it was crystal clear. In the end, I will have an equation, and the equation will be like immersion equals to some resolution times some latency, sometimes, graphics performance or whatever it is, right? And then I will publish it, and 2 years later I will have my PhD, right? No problem. So I started to program, together with some students, some environments in which we can test that, right? So the first of those applications we called Vox Design. So as you can see, my friend and colleague up there in the corner, he is sketching in space, right? So the first application was actually you create things in space. Instead of using your mouse and doing with paint, you paint your flowers in your paint program. You use a pen, you're holding a pen in your hand, and you paint in space, right? And then can you walk around and you see that three-dimensional structure here, and then you can add things to it, and so on and so forth, right? And this is all done with pixels in space, and these pixels in space are called voxels, right? Because they're volumetric pixels. And so you sketch voxels in space, and you can erase them, and then you save them, and then others can experience those worlds, right? Similarly, we designed or developed an application which we call plane design. It was mainly actually for architects. So you want to experience space. And if you want to experience space and you do that on your computer screen, then you can't really relate yourself to that space because you don't know how big is that wall, for instance. If you use virtual reality and you can walk around, and I can draw a wall here, that big, and then it's there. And then I see how big it is, and I can make it bigger or smaller. And I can walk around, and I can have another wall. I can build rooms, and so on and so forth, right? So suddenly I get an idea what that space is about, right? And that was plane design. To do both of those things, we had to develop a certain furniture, and that mainly for two reasons. Number one, probably those of you who have used modern head-mounted display like an HTC Vive will know that when you walk around with your head-mounted display a lot, then you have all these cables running to you. So you have always a second person carrying the cables like with a cameraman. You don't want to have that. You want to have your immersive experience undisturbed. So we need a construction which leads your wires or your cables with you, right? They follow you all the time. And number two, when you're totally immersed or enclosed in that environment, you don't know where the borders are, right? I might easily run into a table or something, right? So here we placed a corner pillows on in reality so that you can feel when you are at the edge of your world, right? So we have a furniture, we have applications, and we can really observe people in action, and we did. So probably myself, I spent hundreds of hours in virtual reality, right, with those technologies. Great experience. Still, it did not really answer the question. So what makes it that I'm in there and sometimes not? What is it? What is the essence of it? Okay, I consulted the old philosophers, right? And not the very old ones, not the Greek ones, but the more modern ones. So three philosophers which really influenced me you can see here. So it's Edmund Husserl with his idea of intentionalism. It is Martin Heidegger with his idea of being in the world, which is very related to virtual environments, as you can imagine. And it's Heinz von Förster, mainly because of his idea of radical constructivism. So it's all about us constructing world. So whether world is really out there or not is not really important. Important is that we know that we construct those worlds, right? And that makes it interesting for virtual reality. So which elements are important that you feel that you are in that world? I make a long story short. It is mainly that we are able to interact in that environment. I can walk around. I see my green cube there. So I'm the one who walks around. I can sketch those voxels in space. So I'm interacting with that environment. That's number one. Number two is that that world has to have meaning for me. In the best case, a plot. It's something tells me that I can do something with it, right? So the world tells me what I can do with it, and I interact in that world, right? These are the two main factors, actually, in what I found out. Whoops, almost undressed here. What I found out from the philosophers. And in addition, my old idea of that kind of immersion with all these technical factors is probably only true in a sense. So probably we need that technology to make that happen. We need the head-mounted displays, the tracking systems, the big machinery, and so on and so forth. But probably the effect I'm after is actually a psychological effect. It's actually my feeling of being in there. It's actually a little bit decoupled from the technical environment, right? I can feel immersed in a very low-resolution environment, or I cannot feel immersed in a very high-res environment, right? So this was what I got from those philosophers. So back to the experimentation, right? So we had all these applications, okay, answering questions. Another experiment. So I explained it very shortly. So this is an experiment where I designed an office floor, right? It's an office floor, and you have a lot of doors, and you have people going in and out on these doors. They come out on one, open the door, go into another, and so on and so forth. So you have actually a busy office environment, right? Unfortunately, we were unable to produce these high realistic avatar characters in that environment. So what we did is we just visualized the shoes of the characters. So you saw shoes walking around in that office environment. That looked pretty realistic, actually, in the end. But how do you do that? How do you create those shoes? Okay, my friend Tore put two of those trackers, which we normally use to determine the position orientation of a user in space. We put them also onto some boots. And then Tore walked all kinds of figures, 8 figures, in-out figures, and so on and so forth. And we played back those figures in that environment. So what it did was it enriched that environment massively. So it was not any longer a dead, unanimated environment. Suddenly it was richer, right? So now it comes to the experiment. So we did 2 experiments with that environment. I'm only talking about the second one. It has to do with what is actually interaction. We had an experiment with 2 groups. So both groups actually saw that virtual environment where these shoes are walking around and the doors are opening and closing and a little bit of sound and so on and so forth. One group was told, you are like a ghost. That environment knows nothing about you and it doesn't react to you, right? The other group was told, the way you walk in the environment influences how these others walking and opening doors and so on and so forth. So you have an influence on that environment. So you are interacting directly with that office environment, right? And then we found out that the group who thought that they can interact with that environment and that the environment reacted actually had a higher level of presence, I call it now presence, than the group which thought we are just a ghost, all right? So even the thought of interaction actually increases presence, which is a very interesting finding in itself, right? So it makes it even more complicated to find out when are we in and when are we out in such a virtual environment, right? So, how to measure? So when you want to measure presence in a virtual environment, it's actually a very tricky thing. So what you can do is you can observe, right? So you can observe people ducking or crouching or whatever, right? Or running away. But it works only for certain environments, right? For instance, fear-evoking or emergency environments or whatever, right? Or you could ask people to click a button when they think we are present. I click a button. But that would destroy the whole illusion, eh? So, are you present? I click the button, oh, I'm not present any longer, right? So it doesn't work, So the only actually valid way of doing it, actually, till today, is you have to ask people. It's a subjective experience, right? So you apply, normally after the experience, you apply a questionnaire. And back then, we had 3 different questionnaires, and all 3 were competing for attention in the researchers community, and they were all very long, right? Psychologists normally develop these very long questionnaires. So we, over time, we developed a very short one, actually only with a good dozen items. So I applied that throughout our experiments all the time and refined it and refined it and refined it over the years. And meanwhile, actually, this is one of the standard instruments to measure presence in virtual environments now, right? It was It's still my highest cited paper. I don't know why, but it's still that one. It was translated into more than a dozen languages, so it's actually a very neat little instrument, and I hope my students will use that too for their studies. Okay. Actually, what we also find out by applying that questionnaire, that we learned a little bit more about that construct presence, what it means. What is it composed of? And it's actually quite a complex model. But it breaks down, in the end, the experience to 3 factors. And one is your spatial relationship to the virtual environment. Where am I? Do I feel that I'm in the center of the room or not? The second one is involvement. Do I feel involved in that environment? And that does not necessarily mean that I think that I'm in the center of the room. And the third one, but it's the weakest, is actually the degree of realism of the virtual environment. And it was an important finding, because now we can actually give up on improving the quality, the visual quality of our environment. It would not add a lot to the presence experience, right? So we can stop it at a certain stage. Okay. Yes. There was a lot of theory involved. It still did not fully answer my question. Actually, it produced more questions than answers. But it's okay, I got some answers. But I was a little bit sick of all that experimentation and of all that doing academic work, right? So I thought, no, I'm going to industry. So I have to see how it really works, right? And so back then, not many industries could actually afford immersive virtual reality systems. It was mainly military, oil and gas, pharma, automotive and aerospace. So I went to automotive and aerospace. So there we had many application areas actually for virtual reality, and we applied them all, right? So for instance, car visualizations is the obvious candidate, right? You pre-visualize, before you produce a product from CAD data, from computer-aided design data. You produce a pre-visualization, and then you can walk around and you can sit in that car and then you can try whether you can reach knobs or you see what is your viewing angle and so on and so forth, right? So that's the obvious one. Or you visualize things you can't visualize normally in reality. Let's say, how is the temperature distribution in this room, right? So I can now walk here and can try to measure it at every point, but I wouldn't do that. So probably we use rather a simulation and visualize that as a virtual reality visualization, right? And I kind of walk around and I see the temperature distribution in this room, right? Okay. Or you visualize things which only some privileged people will ever experience, for instance, in space. Right? We worked on some work with the Columbus module for the International Space Station, for instance. So you can be at that place in space, even if you're not an astronaut, right? But what was really used almost every day, it was used every day, is assembly and disassembly tasks on computer-aided design data. So imagine a car which will come out, or an airplane or whatever, which will come out in, let's say, 5 years' time. But you want to make sure today that when it comes to market, that we can service it, that we can build in the generator at the right place, and so on and so forth. So you could simulate that algorithmically and write in computer programs, but that wouldn't normally not take into account, for instance, the tools you have to use to unscrew it or unbolt it, not the size and shape of the hand of the worker, not the posture in how to put it in, and so on and so forth. So that was actually massively used to test whether you can do certain things before you actually produce the product, right? A very realistic scenario. And I contributed quite a bit to that. Okay. I explored a second area, and that was really there because that was the technology we just developed, and that technology is called augmented reality. And actually, as one of the pioneers of that particular those augmented reality techniques, actually comes from New Zealand, from Christchurch. So Mark Billinghurst back then built a hobbyist kit to explore augmented reality, and I started with that kit. It was in '99, and so it was actually a great way to experience things which combine reality with virtual reality. So up until now, I was only talking about immersive virtual reality. So what you put on your head-mounted display, say, and then you walk around and all you see is virtual reality. So you don't see reality at all. Apart when you come to the edge of our construction and you feel the pillows. with augmented reality, what you do, you keep the reality, but you add certain virtual reality components to it. Let's say I put an object, a virtual object, onto the table. And the trick is, with augmented reality, that I get the same experience. I walk around, and I see that virtual object. Let's say it's my green cube again, but it's sitting on the table. And it sits on the table, I walk around, and it looks like as it would sit there, and I can't actually distinguish it from the reality, right? So this is the idea of augmented reality. So there are a couple of applications for augmented reality, and we developed some of those. Let's say in the first row, this is, for instance, for a design review meeting, right? You have different engineers, they come together, sit around the table, and normally they would prototype a 3D part and would put it on the table and discuss it. But we don't do that prototyping part, we just put the computer-aided design model onto the table. And everyone sees that part from the right angle and as if it were there, right, that part, right? Or down there, that's for an airplane interior simulation. So you visualize different interiors within an existing airplane tube. Or you visualize, as I said before, physics data within a real airplane. So I see the air distribution or the airflow distribution within the real airplane. A very good example for that kind of presence aspect of it is actually the augmented reality driver's training. That's depicted in the middle. So we have a driver and a trainer or an instructor. Both are wearing these head-mounted displays. Different to virtual reality, those head-mounted displays have cameras built into them. So you see the reality by way of mediation of those cameras. So the cameras feed the videos through into your world. So you look around and you see reality. But in addition, you augment virtuality to the reality. And in that case, it would be, for instance, a child jumping onto the street. So you're driving, you're wearing that head-mounted display, you see the reality, but suddenly a child jumps onto the street. So you could say, so what, we could do that in reality as well, but yeah, okay. It's fantastically effective. It really works. When you see that virtual child jumping in front of your car, you brake. Yeah, I can tell you. So it's actually a very interesting aspect. Okay. I make it a little bit more complicated now. Okay, so we have virtual reality, which is an entire virtual experience. We have augmented reality, where we have the reality, where we put a little bit of virtuality to it. And now we mix it even more. Let's imagine we would have that room totally virtual. So the seats are virtual, the table is virtual, the carpet is virtual, the projector is virtual, everything is virtual. But now I reintroduce a little bit of reality, that's you. So I put you into the lecture theater, but you're not any longer here, but you are in Otago or in Berlin or elsewhere, right? So I bring you into that environment, and I see exactly whether Liz is looking at me or at the slides or talking to her neighbor. Right? So I can see that because I see her head turning, right? So now that raises more questions, right? So what does it mean for you being in Berlin, but at the same time you're in this room where you are in Otago and you're talking to each other in that virtual space? So what is the sense of presence for you? Where are you present? In Otago, Dunedin, elsewhere, right? That raises the question of social presence. So we do have spatial presence, we have involvement, we have realism, and we have social presence. That's the experience that we are together somehow, right? In that example, for instance, I'm standing at that virtual lectern, and all these photos you see here is actually actual screenshots from actual applications. So it's not mock-up, it's what you can use. So I'm standing at that lectern giving a talk to a small group of people, and they are at different places. So what does that mean for us and them? How do we experience that kind of collaboration or communication environment? So that's the big question, right? So actually that brought me back to academia. So we come back to academia with less money, less resources, but the better questions. And we use the same trick again. So we are now in a collaborative environment. So we have multiple users in the environment, at least 2. We are coming into that environment. And so how do we make sure, for starters, that they think that they are in the same room, right? So we can't tell. But if we use the old trick of the phobia or fear-evoking environments, then we can be sure that they are at least for that period of time in the same room. Instead of using cars, because they are not that fearful, we use other things, right? Like little animals or spiders or something like that. In that case, what you see is, this is another user, that handsome young man there, right? And this is my view, how I see it with my head-mounted display, right? So I'm seeing that creepy animal there, but let's say the therapist, and that would be the application of it, the therapist is in the same room with me, right? So there's no break in presence. If that therapist, let's say it's a therapeutic scenario, if that therapist would sit outside and would talk to me, immediately I would be taken out of that world. There would be a break in presence. If that therapist is with me in the same room, and hopefully not afraid of little animals as I am, then we are in the same environment, right? So with that, we can establish a ground for exploring spatial presence and social presence again, right? Okay. When you take that one step further, and that's actually a current project by Mohammed. Oh, I don't know. There he is. Mohammed's project is, we have the same scenario here. We have, in his scenario, we have a client, or a client on that side, sitting in front of a computer screen or wearing a head-mounted display, that doesn't matter. And we have an operator or a therapist on the other side. And in this case, the therapist is controlling what the client is seeing. And in that particular scenario, we try to find out whether stressful situations can be provoked purely by virtual stressors. So in a real reality situation, if you see something dangerous happening, you are really stressed, right? So there's no doubt about it. If that stressor is a purely virtual stressor, will you be stressed too? That's the big question. So in Mohammed's scenario, we use that, and we work here together with psychological medicine. This is a postnatal stress resilience training system, right? So in that case, young mothers, after giving birth, normally have to cope with that situation, of that, all these things which are happening at once. And we are simulating that here. And we're simulating that with virtual stress. And as you probably can see, there's that toddler there, and there's something burning on the elements, or playing with medicine or pills, or is near some knives or something like that. We found out that these virtual stressors really perceive stress. So that really works. And now we take it to the next stage and make a real application out of it. Another example where theory work and experimental work leads to applications, right, in that particular case. Okay. Another example for that is Abdul. Abdul is over there. Abdul's scenario, again, we are coming from together with David O'Hare, who is sitting here in front of me here as a co-supervisor. Abdul developed a power wheelchair simulator, and with the help of that power wheelchair simulator, we are answering a couple of interesting questions. For instance, the question about visual dominance and, in virtual environments, or how to navigate in a virtual environment, or how do we perceive virtual environments. But also, we bring it to an application area where we say, can an electrical wheelchair be driven virtually instead of really, in reality? And can we assess people using that virtual environment in the same way as we would assess people using a real power wheelchair? And that means there's a lot of money saving in that, right? So you don't have to ship a real power wheelchair to the potential user and assess them and so on and so forth, right? So in Abdul's scenario here, a user is driving the power wheelchair virtually, and the therapist with the HTC Vive head-mounted display walks around that virtually driving, not really there, user, and assesses whether that user is really driving according to, to the instructions and not bumping into furniture and so on and so forth, right? So we're virtualizing that whole area of assessment in that case, a real application case. So these examples are, and that's the last part of that research part, is actually all the applications you have seen here and all the studies were pretty much replications or extensions of reality. So we take reality and take it one step further, right? We augment physical data to it and show them in the environment, or we virtualize wheelchairs and so on and so forth. What about things we cannot do in reality? We simply cannot do those. So where we need virtual reality or similar technologies to really understand the world, right? So this is an example, and you can try that at the International Science Festival, where we try to give you means to understand four-dimensionality. Four-dimensionality does not mean 3 dimensions plus time. It means four-dimensionality. That means 4 axes are perpendicular to each other. It's a mathematical construct. For the ones of you who are mathematically savvy, that's an easy one. But for the rest, it is probably not. So, how do we, and not only understand, how do we get what four-dimensionality is? So what we do here is actually, we take a four-dimensional cube, which is a mathematical construct, and we project that four-dimensional cube into three-dimensional space. And once we are in three-dimensional space, we use our head-mounted display and walk around and look at that three-dimensional projection out of four-dimensional space. Easy as, right? It's the same, actually, as if you would take a three-dimensional cube, would have a lamp, and the shadow you see on the table, that's the projection of the three-dimensional cube on the two-dimensional table. And when you turn that cube, then you see the shadow changing. The same happens with the four-dimensional cube. If we rotate around the faces, in that case, of the four-dimensional cube, we see the result of the in 3D space of that rotation. So in that particular application, this is Johnny. Johnny's hands are tracked, the movements of his hands, and with the movement of his hands, he's changing the rotations of the four-dimensional cube. But what he sees is the projection into three-dimensional space. So he sees the four-dimensional cube rotating by watching the three-dimensional cube, right? So with that, you get an understanding of what four-dimensionality means. But that is not immediate. That takes a while. So actually, we educate the brain about a concept which we normally could not understand, right? And that's what we are using virtual reality for here, right? So that's the four-dimensional cube. So this is more or less an intellectual exercise, but it has real applications if we think about what can we do with visual manipulations. How does that work with us, right? So we did a project a while ago. I started it, actually. It's called the Augmented Mirror Box. And I did that together with Liz France here and Lee Hale here, for instance, and Nick is not around. So we manipulate or we decouple what you do from what you see. In that particular cases, you put your hands into these two black boxes. They have curtains in front of it. You put your hands into those black boxes. Inside of the boxes, we have some lights. We have cameras, and these cameras capture what's inside of the boxes. And then those camera streams go into a computer, magic happens, and then something is displayed on the display. And it can be a head-mounted display or it can be a screen. It doesn't matter. So normally you would expect I'm having my hands in those boxes, and now I see these hands on the screen, right? A black, white hands, mine, on the black background. But now we start to use these virtual reality and augmentation techniques to educate or fool you around what you're really believing. So let's say we put your hands into it, and the classic is, and that's why it's called the Augmented Mirror Box, because it comes from mirror therapy. You don't move your left hand, you only move your right hand, but you see your right hand mirrored over to the left, and you get the impression that your left hand is moving, right? So that has applications, for instance, in pain management or stroke rehabilitation, right? But what you can also do is you put your hands into environments which you normally wouldn't your hands put into, like into a fire, right? So you can experience real or virtual pain here, right? Or you move your right hand that much, and you see that hand moving on screen, and your left hand you move only a little, but it moves a lot on screen. So you believe that your left hand can move. So it has immediate therapeutic applications, as you can imagine. So we played around with that a lot and did quite a number of studies on it, successful studies, and brought that to a stage where we can do clinical studies on it, right? So we do have a couple of those systems sitting in different laboratories, and for instance with our collaborators in Berlin, because they have more patients, more stroke patients than we have here in Dunedin, and so we are trialing those systems with patients. So again, there's a lot of theory work, there's a lot of conceptual work, there's experimentation going on, and in the end, it's the application we are interested in, right? So that's what we want. Okay. Yes. a current one. I will not talk too much about it. But the question is, when you see all that and you decouple what you do from what you see, then the question arises, how do we perceive our hands? How do we know these are my hands? What makes it me to believe that I own those hands? And it has applications, of course, not only in prosthetic or other application areas, but in terms of how do I explore the world, how do I interact with the world, how do I learn, and all that. And so that's a project we are trying to do now about how is what we see here, how is that represented in the brain? So how can we measure that? Virtual versus real, or all the mixes, right, with all these applications. When you extend that, and that's a recent, very in its infancy project with Katrin and Arne project, which is when you extend that limb thing to the whole body. In that case, we voxelize your whole body. So there's a special camera, and you are wearing the head-mounted display, and you see yourself in the virtual mirror, and then you see yourself moving, and then we start to change your appearance, and we add things to you, and we make you smaller or bigger, or replace parts of your body, or in the end, we might swap. I might swap with Katrin. You see there, so there's a lot of, there are very interesting scientific questions in it, but also applications for that immediately, right? Finally, and that's the final one of those, is that's a very recent project, very recent. And so we tried to find out whether there's a relationship between that kind of feeling I'm there, and I'm feeling those are my hands, and I'm present in that space, and learning. So does that actually lead to improved or worse or whatever learning? So does it affect learning? And does it really require me to be there to learn in a virtual environment? So that's a big question for Johnny's PhD thesis. As a first start for that project, we do have a practical application for that. Actually, we have been approached by the Methodist Mission guys, and they run a project with the Otago correction facilities to support learners in need. So we have a lot of illiterate people there. So what they are interested in is, for instance, cars, right? They love cars. That's fair enough, right? So now, but they can't really read, right? So now we introduce instructions and feedback in written form in a certain way, and link that into that virtual environment. So we piggyback on the idea of a virtual environment to transport learning in that environment, right? So that's actually a very interesting project. We're doing that at the very moment. We just went to the prison a couple of days ago, right? So that's... What George did not mention, the Pro-Vice Chancellor, is that my pre-university, very educated career actually started there. So I went through a 2-year apprenticeship as a mechanic for building machines. So I know how to repair diggers and caterpillars and cranes and all that. And then I worked for a couple of years as a digger driver. So this is where I started. This is the roots, right? This is where I learned about business and the real world back then. And it is still somehow a little bit of a mystery to me how I started as a digger driver in East Berlin, and I'm now a professor at Otago University. And it is. I went through a lot of zigzags, apparently, and probably you know when G.P. Getty was asked about his formula to success, right? So he said, rise early, work hard, strike oil. I get up early, box ticked. I'm not afraid of hard work either, so I think that box is ticked as well. But what about the oil? I really think that my oil is he tangata. He tangata. It's people. This is the point. So without the support, and the love and the guidance and the inspirations of all these lovely people along my way, I wouldn't be here. It would be impossible. Regardless of how hard you work or how early you get up out of bed, you wouldn't be here. So I have to thank all those people. I have to thank my parents and my extended family and my parents-in-law and my son and my daughter. Hello, Germany and Otago. My lovely partner, Claudia. All these people, my friends, my colleagues, those people, brought me to that from digger driver to professor pathway. So that's still I don't get it. In addition to that, when you move to a country, far away from home, and it's at the other side of this planet, right where I come from, you also need those people because they are the substitute for family and for uncles and aunties and for siblings and everything. So I thank especially our friends and neighbors here who did that for us, right? So that's still quite amazing. It's still quite amazing. Yeah, thank you very much, all these people. But I also want to thank, and it's a big privilege to work, to be able to be allowed to work with so many young, bright, interested students. So in classroom, in lecture theaters, in seminar rooms, it doesn't matter. But in particular, I'm really, really proud of my students who are doing my research work with. So we are doing all these interesting things, and you see here that some of those students who share our passion and our interest in all these interesting things and questions. Yeah, thanks students. Thanks a lot, and thanks for coming. Yeah. Yeah, finally, I thought I will have, after over 20 years, you think you will have found the answers to all those questions. I did not. So the green cube is still there, right? I know more things now about it. I know that it is not that immersion equals 2 and so on and so forth. It is probably way more complex. And I'm still keen, I'm still passionate about it to find out. And so the journey is not over, and I thank you very much for your attention. Kia ora.
Good evening. My name is Michael Winnikoff, and I'm the head of Department of Information Science, which means that I'm Holger's boss, at least until the end of the year. Then I can call him boss. So, thank you very much. That was a fantastic presentation, and it gave us really a glimpse into the fascinating and diverse research that you've been doing over the past really couple of decades. And I think it's also given us a glimpse. So these presentations focus on research. As Harleen mentioned at the start, to be a professor at Otago doesn't mean only that you're a great researcher. It also means that you're an outstanding educator, that you serve the university and the community, and that you are a leader. And Holger exemplifies all of those qualities. And what you saw tonight was his ability to communicate and to engage. So you can imagine what he's like in front of a class of undergraduates. And you saw his passion for the topic material. Holger is also an innovative teacher. He's also a multi-award-winning supervisor. I actually forget how many times it's been, 4, I think now. 5. So if there's one thing that I would take away from his presentation, it started with a very simple question. What does it mean to be present? And that was the basis for a diverse program of research that's characterized by incredible breadth. And it's broad in a number of ways. It touches on many disciplines, its foundations. It draws from philosophy, from psychology. It's not just about technology, it's much, much more than that. It's broad in what it contributes to. It contributes back to psychology, back to other disciplines. It's also broad in that it ranges from foundational questions. What does it mean to be present? What are the factors that lead to that? all the way to very practical and quite diverse applications. So I think it's been a fantastic glimpse to some of the research that Holger's been doing. So before I present Holger with a token of esteem, you started the talk with a green cube 20 years ago, and there's a current project that looks at taking a 4-dimensional cube and projecting that. So please come back in 20 years, and I look forward to hearing Holger talk about 5-dimensional cubes. So again, I would like to very warmly congratulate Holger. It's a wonderful pleasure to work with you, and I really look forward to continuing to work with you. And on a personal note, Holger has not just been an outstanding researcher, teacher, supervisor, associate dean research, he's also been a wonderful citizen of the department. He's always happy to help and to do what's best for the department, for the school, and for the university. We're very lucky to have Holger, and I have utmost confidence that when I head off next year on sabbatical, the department will be in outstanding hands. So thank you very much, and congratulations.